Hello everyone, welcome to this session. In this session, I will explain a root finding method called Newton-Raphson method. So let's start its definition. Its definition tells that it is also known as Newton's method. It is an iterative root finding algorithm used in numerical analysis to approximate the roots of a real valued function. Here, please note that the function should be real valued. It is particularly effective for finding approximate solutions to equations where an exact solution is difficult or impossible to obtain. For example, let the function f of x is equals to e to the power x minus 3x. It is a real valued function, means its root are real numbers. Now here I am defining the calculation of Newton-Raphson method. Assume the equation or functions whose root are to be calculated as f of x is equals to 0. In order to prove the validity of Newton-Raphson method, following steps are followed. In step 1, draw a graph of f of x for different values of x as shown below. In step 2, a tangent is drawn to f of x at x is equals to 0. This is the initial value which is given in the question. In step 3, this tangent will intercept at the x-axis at some point x1, 0 if the first derivative of f of x is not 0, whereas f prime of x0 should not be equals to 0. If this is equals to 0, then the value of x, that means root, will tend to infinity. In step 4, as this method assumes iteration of roots, this x1 is considered to be the next approximation of the root in step 5. Now steps 2 to 4 are repeated until we reach the actual root, say x star. Now we know the slope-intercept equation of any line is represented as y is equals to mx plus c, where m is the slope of the line and c is the intercept of the line. Using the same formula, we get y is equals to f of x naught plus f prime of x naught into x minus x naught, where x naught is the initial value which is given in the question, and f of x naught is the value of the function at a point x is equals to x naught. F prime of x naught is the value of the first derivative of the function at a point x is equals to x naught. I hope this is clear to you. Here I have drawn the function y is equals to f of x in the xy plane. Here this is the x-axis and this is the y-axis, and this is the graph y is equals to f of x. We assume that this is the initial value x0 which is given in the question. At a point x is equals to x0, I have drawn a tangent which is look like this, and the tangent is intercept on the x-axis at a point say x1. At point x1 I have also drawn another tangent. This tangent will also intercept at a point x2. Now the process will repeat it up to whether we get the root of the function f of x. Okay, I hope this is clear to you. Here f of x naught represent the intercept and f prime of x naught represent the slope of the tangent, say m. As this equation holds true for every value of x, it must hold true for x1 also. Thus substituting x with x1 and equating the equation to 0, as we need to calculate the roots, we get x1 is equals to x naught minus f of x naught divided by f prime of x naught. Please note that the value of f prime x naught should not be equals to 0. The general formula is x of n plus 1 is equals to xn minus f of xn divided by f prime of xn, which is the Newton-Raphson method formula. Okay. Here I have written some applications of Newton-Raphson method. The first application is root finding in mathematics. The primary use of Newton-Raphson method is to find the roots or zeros of functions given an equation f of x is equals to 0. The method iteratively approximates the solutions by refining guesses. Number 2. Solving nonlinear equations. In engineering and physics, many real-world problems are modeled by nonlinear equations. The Newton-Raphson method is used to find solutions to these equations effectively. Here I have written some numerical problem based on Newton-Raphson method, and these numericals are solved by Python code, and I will show you the Python code next. The question number 1 says that using the Newton-Raphson method with starting point x0 is equals to 3.0, determine the roots of the following equation correct up to 3 decimal places, where the function is given as x cubed plus 5x squared minus 19x plus 3 is equals to 0, and print the root. Here I have written 5 questions, and these 6 questions you may solve it by using Python code, and I will show you the Python code next. This is the Python code. At first I have imported a Python package called NumPy. So first line is import NumPy as np. This is imported for defining the function itself. Here I have defined the function, where the function is log x squared plus 2 minus e to the power minus x by 2. Here I have defined the function as def f of x and returned np dot log x squared plus 2 minus np dot exponential of minus x by 2. Next I have defined the derivative of the function as def dfx return 2x divided by x squared plus 2 plus 0.5 into np dot exponential of minus x by 2. Next I have written the initial value which is given in the question, x0 is equals to 0. Then I have defined the Newton-Raphson method formula. So DEF, which is the keyword, and Newton-Raphson, I taken the name of the function as Newton-Raphson, and there in the bracket the arguments are written f df x0, and here I have taken the tolerance as 10 to the power minus 6 and taken the maximum iteration as 100. Here I have taken x is equals to x0, which is the initial value given in the question. For I in range maximum iteration, I taken the I range for maximum iteration, that is 100. Here f of x is equals to fx and dfx is equals to dfx, which is the derivative of the function. If dfx equals to 0, print 0 derivative, no solution found. I have previously said that dfx should not be equals to 0. Okay. So the x new coordinate is equals to x minus fx divided by dfx, which is the Newton-Raphson method formula itself. If the absolute value of the difference of x new coordinate minus x previous coordinate less than tolerance, then return x is equals to x new, and here I have taken x is equals to x new. Then we find the root, that root is equals to Newton-Raphson f df x0, and here I have printed the root and the value of the function at the root, that is f root. we know that the value of the function at the root should be equals to 0. In this way, you can verify whether the roots is correct or not. Okay, here the value of the root is approximately 0.46 and the value of the function at root is 0 0.0. Here you can see that the value of the function at root is 0 0.0. That means the root is correct. You can also verify by plotting the function itself. Here I have plotted the function by using a Python package called matplotlib.pyplot. So here I import the matplotlib.pyplot as plt and import numpy as np. Here I have taken the x domain range from -1 to 3 and I have taken the number of points, say 50. Okay, so here I written that x is equals to np dot linspace. Linspace means line space. This is the function within numpy. Okay, and this is the initial value, that is -1, and this is the final value, that is 3, and 50 is the number of point that I have said. Okay, now I have plot the function f of x versus x, and I have also plot the root and the root of the and the value of the root at the function itself. Okay, then I have plotted this function. The function is look like this in the domain, my x in the x domain -1 to 3, and this is the function like this, and this is the root. Okay, you say you can see that this is the x-axis and this is the y-axis, and uh, the graph is cut the x-axis at a point 0 0.4. Okay, I hope this is clear to you, and this video is really very helpful to you for understand the Newton-Raphson method and its Python code, and you may solve the numerical problems which is I have shown previously by itself. Okay, thank you for watching these videos.